Hi everyone. In the previous class, we have seen how the files are going to be organized in the hard disk, right? They may be organized in some kind of block by block. When they are going to be organized in the block by block, your data might be spanned or it might be unspanned, right? This is one way of storing, right? Yes. Once they are going to be either spanned or unspanned, again you have to arrange the data. That arrangement can be done either in some kind of organized format or some kind of unorganized format, right? This is what we have seen in the previous class. Now in today's class we'll see the concept of indexing, right? Guys, basically if you try to read any kind of data from the hard disk, for example, if I say there is a hard disk, right? It is going to be divided into blocks, which you know. If I am going to have some records like 1 2 3 4 5 6 7 8 9 10 11 12, right? And this is a kind of a hard disk, or if I say it's a kind of a disk. If I try to search over this disk, it's going to be take more time, right? For example, as here we are going to have 12 records, and which may be spread over 4 blocks. There is no problem for us, right? So means how many block access are required when you are trying to access a particular record? I need to have to search in the block 1, block 2, block 3 as well as block 4 at the worst case, right? So as they are all in sorted order, I can able to apply some kind of binary search algorithm. So you are going to get time complexity of log 4 base 2. For example, if there are something like 1 lakh records are there, then, or something like 10,000 records are there, log 10,000 base 2 blocks, right? So here the 10,000 means it's a kind of a blocks, total number of blocks, right? If I am going to have 10,000 blocks, I need to search for a particular record. How many block access are required? Log 10,000 base 2, which means that here total how many records are there, as per each block requires 3 records, so total 30,000 records are there. That is what my point here, right? If I am going to have 10,000 blocks, in order to find out one particular record block, I need to search over log 10,000 base 2 time complexity, right? Yes. Now the point is, instead of going for like this, instead of going to take this much time complexity, is there any chance to reduce this time complexity or not, right? Yes. So for that reason, what we can do now, we'll try to simply create one small file. That file I can call it as index file, or if I say generally index file, right? And this one if I say technically as data file, right? In index file, what is going to happen now? I am going to simply make use of some kind of values like 1, 4, 7 and 10. 7 and 10. What does it mean as 1? This will be pointed like this, and it will be pointed like this, and it will be pointed like this, it will be pointed like this. Then when user is searching for a particular data, he will try to search for whether it is going to be available in which record, then it will move to the respective thing. Like if I say, again it's going to be divided into blocks once again. You're going to divide into blocks, right? Now in the index file, it is going to be a kind of a block 1, it is going to be a block 2, right? As you are trying to move from data file to index file, number of blocks are going to be decreased. Once the number of blocks are going to be increased, and even they are in sorted order, I can able to apply some kind of binary search algorithm, that is log 2 base 2. So the time complexity is going to be here 1, right? Once it will try to find out the required record is present in the 7th this particular block, then it will move to the respective location, right? So total number of block accesses are going to be decreased when we are going to work with the concept of indexing. right? So this concept I have explained earlier also with the help of an example, that is your record book, right? You can just go through the earlier video or earlier class notes, you can get that clear idea, right? So as part of overview I have given this particular example, right? So if I am going to use the indexing mechanism, you are going to have accessing of total number of blocks is going to be decreased, right? Yes. So if you are able to observe here, so this is a kind of a block. This block contains what? Some of the records, which are some records I have taken frequently, like some random order. So by one is present in this particular block, this is a pointer, and this is a pointer, this is a pointer, this is a pointer, right? This is a pointer pointing to this particular block, 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 right? Guys, if you are able to observe, this is a block. This block contains a record, but this record size is very much length, right? Meaning that the data record, this is, I can call it as technically the data record size is more, whereas coming to this particular one, I can call it as also record, but this record is belongs to what? Index record, right? If you are able to observe in the index record, how many fields are there? This is one kind of a field, I can call it as a key field, and another one is a kind of a field, we can call it as a block pointer, which can store the address of one particular block, right? Yes, if you are able to observe this particular block, it is going to be pointed. So this is the structure of one particular index record, right? So if I say the structure of an index file, it is going to have a collection of keys, so this is key, and collection of block pointer. So key followed by block pointer, this thing I can call it as and simply an index file. So index file size is far less space occupied compared to data file, right? So I hope you understood now, right? So if I am going to say on this particular index file, I can able to apply again binary search as this is a particular block 1, this is a particular block 2, and so on, right? So that its time complexity is going to be reduced. For example, in this particular index file, if I am assuming that BI number of blocks are there, if I am going to apply the binary search algorithm, you are going to get a time complexity of log BI base 2. Log BI base 2 is the time complexity, right? So once I have applied the binary search, I can able to get a particular block, right? Once I get the particular block, I need to find the number of block accesses, the total number of block accesses. The total number of block accesses will be how many, right? We need to search for an index record block. Right? In index record, how many block accesses are required? Log BI base 2. Once I find a particular block, then I need to go for once again the respective block of the data file. So I need to have the constant time, that is log BI base 2 plus 1, right? So this is meant for data block access, and this is meant for index block accesses, right? Yes, I hope you understood this one clearly, right? Now, as I have taken here 1, 4, 7, 10, you may get confused, right? What might be these values, right? These are the sum of the values that I have taken from the actual data file, right? That data I have taken some kind of random order in this particular example, but in the reality, this index keys, I can say them as index keys can be created with the help of any kind of procedure. I can say that can be created on any field of data file, guys, right? Data file. Now in this data file, your data might be contains a keys, meaning that any key data may be there, or it can be a kind of non-unique data also, non-key data also, right? So means if I try to elaborate, if I am going to have a particular data file, this data file can contain multiple records with multiple fields. One might be a kind of a key field, one might be a kind of a non-key field also, right? Now if I am going to create one index file, obviously it is going to have key followed by block pointer, Here I can able to use either a key or I can able to use a non-key also. So depending upon what you are using, in the key location, in the key field, they classified it into again different types, right? Yes. So basically if I say various types of indexing, they have classified it as, the general terminology as, one is single level index, another one is multi-level index, guys, right? So basically what is the meaning of single level index? So far whatever things that we have seen, right? So if I say this is a kind of a data file, on this data file we are going to have one level, right? So this data file is level 0, and this data file, this index file is level 1. So we are going to have single level, we can call it as a single level indexing. Multi-level indexing means if you are going to have many levels, if you are going to have more than one level, I can call it as multi-level index. Basically the examples for multi-level indexes are ISAM, b+tree and b+trees. These are the examples for multi-level index, right? So that we'll see in further classes. So coming to single level indexes, so I said, right, we are going to have level 1, where in level 1 we are going to create an index file. That index file contains contains two fields. One is a key or non-key field, another one is a block pointer, right? So based on that scenario, they classified it into three types. One is a primary index, another one is a cluster index, another one is a secondary index. Primary index, cluster index, another one is a secondary index, right? So when I can say a particular indexing mechanism as primary indexing means, suppose if your data, if in the disk your data is going to have some kind of a key, and this data is going to be in some kind of ordered format, then there might be many advantages for us. Right? What might be the many advantages? I can able to create an index file. So I can technically call this as an index file, and this will be a data file, right? Guys, according to our religion, if I say if this data contains the all keys, all are unique values, something like 1 2 3 4 5 6 7 8 9, all are going to be some kind of keys, and it will be in some order. Then what might be some advantage over this one? I can able to connect it to this point, this block by just making some kind of key here. Say I have taken some here as 1, and for this block I am going to connect it. I have taken some key value here as 4. I have connected this one as 7, and I have taken, right? It's not only about like 1, 4 or 7. It can be any value of this particular block, right? But as it is for easy, I have taken this like this, right? Now if you are able to observe, as my data is available in the form of key and ordered data, I have this option. I have this option to take, right? So what will happen here? Now if somebody is searching for certain data, something like 4, I will try to take for whether it is going to be available in which block, right? Now this entire thing is going to be one particular block, because in each and every block I can able to save 3 records, right? So this is one particular block now, right? 4 is available, that will be related to this particular block. Yes, right. So the advantage of primary indexing is, so when we go for primary indexing, if your data is going to be in some kind of a key and in some order, then I can go for primary indexing. Right. So here the technical terminologies are, as I have taken from this block first file I have taken, from this block first file I have taken as a key, from this block first file I have taken as a key. All these three I can generally call it as block anchors. Right? Yes. So block anchors are there, right? Now guys, in index file, how many records I have taken? So number of records in index file is equal to number of blocks in data file. How many number of blocks are there in data file? That many number of records are going to be available here, right? Yes. Based on this, it is easy for us to make it apply some kind of binary, right? Now on this I can able to apply some kind of binary search algorithm. Yes, right? So if I am going to apply binary search algorithm, so number of blocks are BA, then log BA base 2, right? And once you need to access the next to respect to block. So for that I need to go for +1, right? So total number of block access in primary indexing, total number of block accesses in primary indexing are log BI base 2, which is for the index file, and in the data file how many block access you are going to access? 1, right? So which is something like log BI base 2 +1, right? Yes. So technically if I say primary indexing means it's a kind of an ordered file. It's an ordered file here whose records are going to be of fixed length, with two fields. What are those two fields? One is a key field, I can say directly as primary key field, and another field is a kind of a pointer. We can say them as block pointer. This is what the primary indexing mechanism. Okay, fine. Hope you understood clearly, right? So if I say in another words, if I take something like this, if you think about this particular scenario, one technical term I would like to introduce here, right? So here I am going to have some kind of a blocks in the disk, right? And I am going to have records, something like this, right? Yes. Now if I have created one kind of index file which is equivalent to as something like 1 2 3 4 5 6 7 8, meaning that it is going to be connected like this, right? How it has connected, guys? Right? For each and every record they have one block pointer, they have one pointer, right? So that can be a block pointer, that can be a block pointer. So means simply I can say that for every index entry which I have created, for every search key value, then I can say this particular mechanism is called as dense index mode. Hope you understood, right? So meaning that here if I am going to have how many search keys are there, you are going to have 8 search keys are there, you are going to have 8 index records, then I can call this as dense index, meaning that for every data record of the data file, if I am going to have index record in the index file, then I can call it as dense index. See, it is completely dense, right? So for example, if I say some another example, if I try to say 1 2 3 4 5 6 7 8 9 10 11 12, and I am going to have an index file. This index file contains only something like this 1 4 7 and 10, and they are going to be connected like this, right? Now is it a dense? No. For every search key value they haven't specified any index entry, right? For few only they have specified index entry. Then I can call this as sparse index, right? Meaning that index entry is going to be created, index entry created only for few records. Then I can call it as a sparse index. Sparse index, right? For example, if I say this one 1 2 3 4 5 6 6, something like this, now I have created one index file 1 2 3 4 5 and 6 and 6. Now can you tell which this one will becomes under dense or sparse, right? So this will becomes under dense index as well as sparse index. Why? Because for all search key pairs they have created index records, and for few records, meaning that for few records there will not be any kind of like we can say index entry. It is not available, right? So it will be connected to this one, so this is not connected, right? So it is called as sparse index. Dense means what? For every search key there exists index record, so I can call this as dense index, right? Based on this concept, can we say this primary indexing mechanism will becomes under dense indexing or sparse indexing, right? So here I haven't created index record for every record, right? Every data record, so I can call it as this as sparse indexing. Right? Yes. Fine. So this is what the mechanism is going to be followed in primary indexing, right? So next one, let me take the cluster indexing. Right? So guys, in cluster indexing, so you are going to have basically, you are going to have a data file. This data file contains non-key data, guys. In primary key indexing we are going to have a key along with ordered data. Here it is going to have a non-key along with the ordered data, right? So as you are going to have non-key, something like this. So if I say 1 2 3 3 4 5, something like 6 6 7, like assume that, right? This is one particular block, this is going to be one particular block, right? Yes. So if you are able to observe, this is a non-key because two duplicates are there. Here at least one duplicate is there in this particular record, like field. I can say it is non-key, but anyway they are in some kind of ordered format. At this particular scenario, if you try to create an index, how we are going to create an index? You can able to create the index for every non-key field. We are going to create the index for every non-key field which are having the distinct values, 1 2 3 4 5 and 6, 4 5, right? Now it will be connected like this, 2 will be connected like this, 3 will be connected like this, and 4 will be connected like this, and 5 and 6 and 7, I forget it, 7 will be connected like this, right? This is what clustering index is means, right? Meaning that in clustering index we are going to have the non-key plus ordered, means the key is a kind of a set of distinct unique values and a block pointer, and for each every index record they are going to be respect to 5, right? Yes. At this particular scenario, so how many number of index entries which will be defined based on number of key values. What are key values? Out of those non-keys, what might be the unique? We can say as number of distinct values. That many number of index entries are going to be happen, right? Based on this, can we say whether it is a dense index or sparse index? Can you define? I can say this will be sometimes act as a dense index and sometimes will act as sparse index, right? According to this particular now figure, what you are observing will become a sparse index, because for every record you are not going to have any kind of index entry, right? So we can call it as sparse index. Dense means what? If suppose the chance is that if all the non-key fields also contains the data are something like distinct values, then it may act as dense, meaning that sometimes it may act as a dense index, sometimes it may act as sparse index, right? So but and one more thing is here, how many number of block access are going to be required, right? You know, on this particular thing you are going to apply some kind of binary search algorithm, that is log bi base 2, and once you identify one particular block, you are going to move to one particular block, like this particular block. You move to this particular block, right? You go on for that number 3, right? Yes, fine, block access done. But this 3 is available not only here, it is available also here, right? Meaning that there is a chance of your record might be in spanned mode, right? They may be in more than one block, right? So number of block accesses required in clustering index will be greater than or equal to log bi base 2 plus 1, right? So this will be, I can say that average number of block accesses, in cluster index will be log bi base 2 plus 1. Hope you understood, guys, right? So next one is so it will be kind of a theory. So in the coming class we'll try to take the various kind of problems which we can able to understood the complete in depth about the concept, right? So those are some kind of gate related questions. And next kind of indexing is secondary indexing, right, guys? So far we have seen, we are trying to take only the data on ordered data, right? The data on ordered file. Now in second index is going to be concentrated on unordered files, right? Unordered files, right? If we say something like this, something like 5, 11, 7, some data like 6, 12, 13, something like this, right? This is a kind of unordered data, right? This is unordered data. On this unordered data, it is going to apply some kind of indexing mechanism. Again, this will be a kind of ordered data now. A kind of ordered data, right? Meaning that once you have taken the unordered data, there might be certain kind of other fields. They might be ordered. Right? Yes, they might be ordered. So we are going to apply some kind of secondary mechanism. Here the data will be some sorted order: 5, 6, 7, 11, 12, 13. Because why I am going to apply some kind of sorting mechanism here? Because I can able to apply some kind of binary search easily, so that your time complexity is going to be completely reduced, right? So that's why I am going to place it in some kind of ordered format. Once I place some kind of ordered format, how many records are going to be there here? See, in every indexing I am trying to say number of index records. So this will be the important one. So number of index entries are going to be number of data records. How many number of data records are there, right? How many number of data records? 6 data records are there. 6 index records are going to be available in secondary indexing. Because all are zigzag order, those should be placed in some kind of order. Right? Guys, you have to observe here. If I say this is a kind of a key value only, this is a kind of a key, right? There are certain situations where some might be another kind of a key also, right? So if we are going to have more than one key, I can call them as candidate keys. Right? Now I can make order on one particular, sorting order on one particular key, and I will try to search for on another key, right? So that is the reason we are going to call it as secondary indexing, right? So your data will be in some unordered format. Your data will be some unordered format, and I am trying to apply some kind of search mechanism on some kind of a key. Then it is called as secondary indexing. Secondary indexing, right? Yes. Fine. So then what might be the remaining parameters I have to define? So now tell me whether it is a kind of sparse index or dense index. It will be dense index, because you know, for each and every record there will be definitely one record pointer. So I can call it as it's a kind of dense index, right? So simply what I am trying to say is, if I say it's a kind of primary indexing. In primary indexing, you are going to have primary key along with the ordered data. In clustering index, you are going to have non-key, but your data will be in some kind of ordered data. In secondary indexing, you are going to have unordered data. I will try to write in order only. You are going to have candidate keys. There might be more than one key. You are going to have candidate keys, and the data might be in unordered format. Right? Yes. So this is what the concept of indexing, right? Okay. So in the next class we'll try to see various kind of problems on this, right? Hope you understood clearly. Thank you.